Now, in step 6, we need to organize our data in a visual way by creating a graph of our information. In the field of science, we try to keep things clear and simple with our graphs. If you'll notice on the graphing template I've provided, you will see that the independent variable is most always on the bottom of the graph, which is the x-axis. You can remember this using a simple hand gesture of crossing your arms in the shape of an X and then folding them down one on top of the other, representing the bottom horizontal line of our graph. The vertical axis is the y-axis, which is where we place our dependent variable, our measurement. You can remember this by placing your arm up and spreading your thumb away from your fingers, thus making a Y shape with your vertically placed arm. Remember to always make sure you label everything on the graph. One of the ways in which we can best remember everything about graphing is to use a popular mnemonic, dry, mix, tails. Using dry mix helps you to remember which variable goes where on the graph. D stands for dependent, R is responding, and Y stands for y-axis. M stands for manipulated, I is independent, and X is x-axis. As for tails, this is our rubric for making a clear and well understood graph. T stands for title, which needs to be appropriate and descriptive. A is axes, which needs to have the correct variable placed on each one. I is interval, which should be evenly spread out for the graph to keep it clean and organized looking. L is labels, where both axes and the unit used are clearly recorded. Finally, S stands for scale, which should be appropriate to the data. This is important visually since it is here that someone can make the data look differently than what it is really saying. For example, if I were plotting two data points of recorded temperature between 2 days, one day being 91.3 degrees Fahrenheit and the other 92.4 degrees Fahrenheit, and I plotted them in a graph whose scale was 91 to 93, then it appears to be a massive spike in temperature. However, if I take the same data and plot them on a graph whose scale is 0 to 100, then it appears that there was very little change in the temperature between the 2 days. When graphing, it is important to consider how best to accurately portray your data in a clear way. Thus, by using dry mix tails, you can accomplish a well-produced graph every time. Let's now plot our helicopter data. I have clearly labeled every part of my graph to make it clear to the reader what is being portrayed. My scale is between 1 and 2.3. However, I labeled them as 1.00 and 2.30 due to my data having 3 significant digits such as 2.19. When we plot the data and create a bar graph to represent the data, we begin to see the difference between each independent variable of wing length. I then placed my exact data points on top of each graph and gave each bar a different color in order to make it more clear to the reader what the data is showing. We can evidently see the long and medium length rotor wings are fairly close in flight time, but the longest rotor wing clearly has the longest flight time, or time of descent, thus giving support to our hypothesis.